Good noon, everyone, and welcome to Skylab. Whether you're joining here face-to-face in the room, I see people are still coming in, or whether you're online joining us for the live stream. Just for the record, it will also be possible to review the talks afterwards, view on demand, so you can share these talks with friends and colleagues. Today, I'm very thrilled to be able to present to you Nikolaj Monson Olsen, who's going to be on stage shortly. He's a data architect from BKI. I've never said that in English before, I think. A coffee company. So it might surprise you that you can actually use AI to develop the perfect cup of coffee, and he will tell you how. After that, and after some questions from you guys to Nikolaj, we'll hear from Andreas, who's joining us from Ambolt AI in Aalborg. In fact, we have a strong representation from Jutland today. I'm from Aalborg. Both our speakers are from Aalborg. We did not plan it that way, I promise, but it's going to be fun to see how that's going to play out. If you're joining us online, please leave any comments or praise or questions that you might have in the chat, and then we'll take them during the question breaks. Cool. Well, without further ado, I would like to welcome Nikolaj on stage. Please give him a warm welcome.
Right. Hello, my name is Nikolaj. I'm here today to tell you a bit about our work at BKI on using AI on something as subjective as the taste perception of a food product, and how we've been able to build an AI tool not only able to predict the flavor of any combination of coffee beans, but also a tool able to aid us in deciding how we should combine these coffee beans in the most cost-effective way. A very quick recap of my role at BKI. I've been employed there for a little over 7 years, some 6 years as a business analyst, and for the past year or so as a data architect, primarily focusing on digitizing our production and building the foundation for more advanced analytics and most recently AI and machine learning. BKI is a Danish family-owned coffee roasting company based just outside Aarhus. We sell approximately 10 million kilograms of coffee a year. We receive, roast and package all of the coffee on our plant in Aarhus. Our products are a mix of private label products and our own brands. And besides coffee, we're also a distributor of some of the bigger brands you may see in the retail setting, such as the Checo pastas and Lindt chocolates, but coffee is our primary purpose as a business. First, I thought a little background and information to set the scene for you. Whenever you talk about the flavor or taste of a coffee, this is determined with a process known as cupping, much like most of you probably know from wine tasting, where you take a sip of the beverage and taste it and spit it out, and then you rate and describe the flavor on certain parameters. Similarly, you do with coffee. At BKI, we do this on 4 parameters: acidity, body, aroma, and aftertaste, each on a scale of 1 to 10. And collectively, these 4 parameters are referred to as the flavor profile of a coffee. At BKI, we sample and cup every single container of green coffee we receive before it's used in our production facilities. Similarly, every single product we produce is sampled and cupped before it's shipped to our customers. And all in all, this adds up to somewhere between 200 and 300 cups of coffee being sampled every single day. Going back 2 or 3 years, all of this was done on paper, both documentation and noting of these cuppings, which of course made any fact-based analysis in regards to flavor impossible for us to do. So a few years ago, we began building an environment of connected applications, which allowed us to digitize all of these cuppings for both our raw materials and finished products, and allowed us to start collecting data and build a high quality data set to work with. So in other words, we replaced this filing cabinet here on the left with a database and a couple of smartphones to begin our journey. So after having done this for a while, we obviously began wondering how we could utilize this data to create more value for us other than just having it lying in a database somewhere. At this point in time, we got offered to participate in a sponsored project called AI Denmark, which has the goal of helping Danish companies see the benefit and value of using AI or machine learning in their day-to-day work. So after starting our participation in this project, we debated with the team we were assigned how we could use this data, and we settled on a topic of trying to see how we could utilize our data to help us combine our green coffees in new ways in order to achieve a required flavor profile of our coffees with as low product cost as possible. And while this may sound like the job for an innovation department or a product manager, if you consider that BKI we have 70 different defined types of green coffees, we're able to produce coffees with anywhere between 1 and 7 different components with proportions as low as a single percent, and several other factors we're able to fine-tune to affect the flavor of a roasted coffee. We're looking at a theoretical number of combinations like this, 99 sextillion or 21 zeros if you're counting, so obviously an impossible number of candidates to consider for any human or computer for that matter. So what we were trying to do was to, like I said, utilize our data better, and all the structure we had ended up building across our systems. Very simply said, we know exactly which containers we receive at any point in time, and we know the exact flavor profiles for each of these containers. We know exactly which roasting orders each container has been used in and in what quantities. We know which finished products each roasting order has been used for, and we know the flavor of each product. So we have built a way to relate the flavors and other characteristics of our raw materials up against the flavor profiles of our finished products. And this whole relation is what we're trying to utilize to teach an AI model how to predict the flavor profile of a finished product. So our initial attempt at this was built in collaboration with the Danish Technological Institute, an AI solution consisting of 2 modules. The first module consisting of a neural network supposedly able to predict the flavor profile of any given blend of green coffee beans. And while this, of course, is very impressive to be able to do, it's still not anything really usable in our day-to-day work, given we still have that huge number of potential candidates to evaluate on. So to help solve this issue, we built a second module and consisting of an evolutionary algorithm or genetic algorithm, which very simply explained creates a lot of random blends with random components and quantities, evaluate on these through a scoring function that's a product of, in this case, flavor and cost, and then continuously over 50 iteration continuously tries to improve on these random blends, only to end up producing a list of the best candidates it's been able to create over however many iterations we ask it to do. So through a solution such as this, we're able to go from having to look at those 99 sextillion candidates to only having to address 50 candidates when trying to improve our products. So of course we did some testing and pretty quickly realized that while the proof of concept was very strong, it wasn't accurate enough for it to be usable in our day-to-day work. We had too many suggestions, too far from the actual results when trying them out. So of course we began wondering where we were going wrong. Is it data issues or wrong choice of model or perhaps something else, or was it even possible to do this? So I'll try to give you a few examples of the most interesting pain points we experienced during this process and how we tried to mitigate these and the final result we've ended up with today. The biggest challenge in all of this model building and being able to predict the flavor profile of a blend of coffee beans is actually related to the scale we use for grading. The problems with the scale is it's the humans doing it, but if you could consider whenever any of us are asked to fill out a questionnaire and rate something on a scale, I think we're seeing the same tendencies as we're experiencing in doing this. One would probably assume that a 1 to 10 scale is linear, so the difference between, say, acidity 5 going from a 5 to a 6, one would assume that it takes just as much to go from a 6 to a 7, for example, but that doesn't appear the case. So much like rating something in a questionnaire, it takes more to go from 6 to 7 than it does 5 to 6, for example. So it's not a linear scale we're working with. And similarly, we have a tendency not to use the outer edges of such a scale. So we're rarely seeing any values below 3 or above 8 for that matter. So while on paper we're looking at a 1 to 10 scale, in reality it's actually a 3 to 8 scale we're working with, which makes for a much more condensed interval of numbers to work within and makes the prediction accuracy that much more important. And in addition to this, you also have the people doing this. We're not machines, so you can't expect any of us to be perfect, especially not when it's something like flavor or taste. Even something as simple as having a good or bad night's sleep or a horrible morning or whatever on your commute to work can affect how you perceive the taste and flavor of a cup of coffee. And of course you also have multiple people doing this cupping, so you also have to ensure that the perception of a flavor is the same across the people doing this cupping. So if you and I taste a cup of coffee is a 4 in acidity, do we have the same perception of what constitutes a 4 or a 5 for that matter? So currently we're looking at a variance amongst our cupping team anywhere between 0.4 and 0.8 of a grade, which is fine, but this also has the consequence that our model is never going to outperform this variance when we're looking at the suggestions. And of course, we also had to take a good look at our data representation and feature engineering when building our model. All of our data is based on batch data from our production system, so we have several hundred thousands of records. If we decide to use that level of granularity, you could also aggregate to a very condensed and limited data set, which is actually what we've ended up doing. So what I'll show in a bit is actually based on as little as 3,100 records when training our model. But I think the process around this data representation and of course feature engineering is something that caused a lot of frustration among the non-technical participants in this project, seeing as it's not a linear process. You don't just decide on a way to represent your data and features and then that's done. It's a circular or iterative process you do many times over, which can be a little difficult to understand for the non-technical participants. But by the end, we found the right way to represent our data. Like I said, a very aggregated data set. Tried out a bit more than 130 different features, and 7 proved useful in our final model. And of course, we also had to take a look at which model to use when predicting the flavor of these blends. We started out with a neural network proposed by the Danish Technological Institute. We very quickly realized that this was a much too complex model, both for the problem at hand, but also in terms of maintenance and further development going forward. Then you also have the option of linear regression. At the moment, this is proving too simple of a choice for a problem at hand. Probably also related to the variance amongst our copying team. So we settled on a random forest model, primarily because it was much easier for us to maintain and further develop ourselves. But we also, of course, saw a great increase in accuracy in its results and a reduction of these far away from reality suggestions put forward by the model. And in regards to our genetic algorithm, we actually saw very little need for change to that. So most of our issues stemmed in the ability to predict the flavor of these blends. So what have we actually been able to build? We've built an AI solution still consisting of 2 modules like before, the genetic algorithm and now a random forest model able to predict the flavor of any combination of green coffees we send in. We have put the model into production, allowing specific users to initiate the solution through a user interface where they can enter the flavor profile they're looking to create and define any constraints as for which green coffees the model is allowed to use when it creates its suggestions. Through this, we've been able to create or make several AI-based changes already in our production system, as well as new products. And as of yet, the model itself is not autonomous, so we're always testing out the suggestions before we're putting them into production. Looking forward, the biggest ambition is, of course, to have an autonomous model being able to define how to roast each order based on the different use cases and the availability of raw materials. As for use cases, we obviously see this as a way to help us in reduce the cost of our blends without compromising on the quality or flavor for each product. We're also seeing a tendency in the suggestions put forward by this model to simplify our way of blending coffee beans. So where we would have maybe 6 or 7 components before, we're seeing a tendency to only use 4 or 5, which make for a more streamlined and simple production setup and a better utilization of our equipment. We see one of the biggest benefits of a tool like this is our ability to use it to mitigate some of the risks we are seeing in our supply chain. I think most of us have seen how quick the world can change over the past few years. So availability issues or transportation issues and what have you. We now have a tool able to help us react to these very much quicker than we were able to do before. We've seen it as a great way to optimize our workflow in regards to innovation and new products, where you had to start from zero before. You now have to open a UI, enter a few parameters and wait 30 minutes, and then you have 50 very qualified starting points to look at. And last but not least, we're seeing a possibility to use this tool as a way to help us with this whole green transition in phase or environmental focus, where we currently have a model focusing on flavor and cost. We're now also looking into adding a third parameter with CO2 emissions. So rather than having a model only trying to optimize on cost, we're now able to ask it to produce a specific flavor with as low as a carbon footprint as possible as well. So all in all, a tool allowing us to be much more proactive in our way of facing the challenges we see now and in the future, rather than being reactive. Wonderful. Yes.
Thank you so much, Nikolai. Let's see. Do we have any questions in the room here?
Yeah, I was wondering, since you're working with biological samples, if you've run into any complications with synergistic or antagonistic or other effects, where you, for example, mix two bitter coffee beans and then suddenly it tastes less bitter.
Yeah, that's one of the challenges we've been facing. We are seeing a slight tendency to that 1 + 1 doesn't always equal 2 when combining coffee beans, and we haven't found a statistical sound way of proving what's actually happening. But we're seeing exactly what you're asking, that sometimes if you have a coffee with say 9 in acidity or 8 with a low percentage, it actually has a tendency to influence the acidity of the final blend with an acidity higher than what you would expect. So yeah, that's one of the issues, and ideally you would of course have some way to build this into the model, but we haven't found a statistical way or a right way of telling the model how to predict these.
I guess it would require you to know exactly what chemicals are in each bean for you to do that.
Yeah, and there are companies around the world that produce and sell gadgets you can use to get a chemical fingerprint of each coffee bean, but then you'll just face the challenge of translating your chemical fingerprints to a grading scale, and then you have the same uncertainty as we do currently, where you have the human factor in translating a chemical fingerprint to our own scale. But yeah, several companies are working on producing a more mechanical way of defining flavor, but most of them are still dependent on a human to translate the chemical fingerprint to a 1 to 10 scale, for example. Yeah.
Any more questions?
I don't need the microphone.
Well, you do for the streaming.
So have you thought about the scalability of the random forest if you're going to add a lot more variables? Well, like compared to a neural network or something?
The short answer is no. A bit longer answer is we're not seeing a lot of extra features necessary to add. I think if we change any of the features we currently have, it's probably only going to happen if we choose a different way to represent our data.
Okay.
Yeah.
Yes, we have one up here.
Thank you, and very interesting talk. I would like to go further with Jakob. Did you try to use easy control to test your model, like Arabica versus Robusta. We know that at the end the taste is going to be really different, and like it will prove that your model is working.
Yeah, the testing has basically been done by getting the suggestions from the model and trying them out in a testing lab. So we've tried blends with pure Arabica and pure Robusta and mixes and different qualities for Arabica as well in different proportions. So when we say we have a functional model, this is based on actually trying out the suggestions in a real life setting, and the changes I mentioned before have also been done on full scale to be verified as accurate as well. Yeah.
Okay. And after you were talking about chemical fingerprints on the beans, did you try to have a standard coffee cup and chemical fingerprint of the coffee cup to see if it can replace the human bias? Because I think the tasting will change from everyone.
We haven't tried in a liquid form as of yet. Most of the companies I've been in contact with are looking at being able to scan the green coffee beans and converting this to a flavor.
Yeah, but after you put it in an oven and things like that, that completely alters the taste and develops the taste. So I think from the green bean might be difficult. I will go for the standard. Thank you.
I think the difficulty in that approach as well is it's much too time consuming for it to be worth the effort for us. We're not big enough to spend a full-time employee on taking samples of brewed coffees to get these fingerprints. So maybe in a bigger scale like Lavazza or a company of that scale, it would make sense. But for someone like us, it's too much work to be worth the effort.
Okay, thank you.
Any other questions in the room? Do we have any questions online?
Well, I actually had one from BKI, but it was going along the same theme, replacing humans for setting a fingerprint.
No. I'll repeat again. No, we had one from Ben Cahill regarding replacing humans with a digital or a robotic fingerprint. So I think you have answered on that.
Yeah, I don't really see this solution as a complete replacement of people, but more as a supplement and make us less dependent on key personnel in our companies. We still need to feed the model the data, and that data is currently only able to be provided by trained people.
Thank you.
Any new questions in the room? If not, I'll sneak in one. I know that you're part of the AI Denmark competition, and you won the competition. So congratulations on that. Could you speak to what that experience was like?
Well, a very positive experience, first of all, and I think for a business or company such as BKI, we would probably never have been able to look into AI without having such a project as a starting point. So for us, we wouldn't be working with this tool if we hadn't participated in such a project and gotten in contact with the people we got in contact with through AI Denmark. So for us, it meant everything in regards to AI and machine learning.
Very cool. Well, thank you so much for your talk. You'll be around if people have questions later on.
Yes.
For now, we're switching speakers. I'm welcoming Andreas Baer Eriksen from Ambolt up here, and we'll be right with you.
So, first of all, welcome. I know you were all promised a lunch talk. I hope a little bit we can turn this into a lunch chat instead. So if you have any questions, anything you want to talk more about as I'm going on, I mean, feel free to interrupt me at any moment to discuss anything I'm talking about, because I really enjoy when these things are interactive all the time. So yeah, I hope we can turn it into a lunch chat instead. My name is Andreas Eriksson. I'm here to talk a little bit about what we do in Ambolt AI, specifically how we build human-centric AI solutions. First of all, a little bit about myself and my background. I'm a Master of Computer Science from Aalborg University. I then went into both being an entrepreneur and into academia just around the same time. So the academia part I will not talk very much about. One of the cases I have with me today is the result of what I did on my PhD. But the main thing here is what we actually do at Ambolt. I'm one of the founders of the company, and we founded the company while we were still students. So I really love what you're doing here at Skylabs, where you're sort of really focusing on student entrepreneurship and making sure innovation from the university sort of flows into the real world. I mean, I'm really, really a big fan of that. First of all, one of the reasons I think it's really, really important to talk about human-centric AI is because this technology is something that will have a broad impact on many, many sectors, but it's also a technology that I would say perhaps have been a little bit overhyped. So that means many, many organizations started doing something a little bit like this, with the square hole being AI and all of the little pricks being problems they had.
This is a square. Can you guess which spot that goes in?
The square.
That's right. It goes in the square hole.
Yes. Okay.
And how about this rectangle? That one?
Also the square.
It goes in there too.
Yeah.
Up next, we've got this thin rectangle.
The thin rectangle.
Can you guess where that goes?
The thin rectangle.
That's right. It goes in the square hole. And up next, a cylinder.
The circle.
I think that goes in
the circle.
The square hole. Now, we've also got this semicircle right here. Do you see a slot that would fit
the semicircle?
Semicircle?
The semicircle.
That's right. It's the square hole. Okay. Up next, the triangle. We know what hole that goes into,
triangle.
right?
Triangle.
That's right. The square hole. And up next, we have the arch.
The arch. The arch.
You guessed it.
The arch.
It goes in the square hole.
God.
So as you can see, it can be pretty frustrating when you're sort of applying the same technology to every single problem, as though it's just something to solve your underlying problem. And being from computer science and really being into AI and data science, today I've decided to include a negative example and a positive example of how I think we should build AI systems. And I really always like to start with the negative one. So let's dive a little bit into some computer vision. This is an X-ray scan of a chest. And just a little bit of background information. During the COVID-19 pandemic, I think many people around the world was in an immediate panic to sort of see how can we use technology to really better the situations at the hospitals, because now they're overflowing with patients. How do we decide which patients to treat, and so on. So one of the obvious ideas here is to use AI and machine learning, computer vision, for X-ray images to sort of try to, for the different patients, predict how severe will this patient be affected by the COVID-19 pandemic, meaning how much capacity should we set aside to this patient, and so on. And this was something I think more than 250 research teams were working around the clock on. And a lot of software was actually built and put into clinical use. So what kind of features do you think is important when you look at an X-ray like this for deciding how severe a COVID-19 infection will be of this patient? Anyone? Perhaps by a raise of hands. Should it be the text up here? I guess not. Should it be rather not the patient was standing up or lying down when X-rayed? Also, I guess not. But actually this was the case with almost all of these models, because you had no idea of how the dataset was gathered. You had all of these teams working around just applying convolutional neural networks to a bunch of images that, again, they had no idea what was going on. And there is a great MIT article about this, where, I mean, hundreds of tools were built and none of them were fit for clinical use. And sadly, many of them was actually used for clinical use, meaning that patients were treated wrongly. A lot of people were sort of, really looking for AI for assurance here, and instead what they got was frustration. So a really horrible case of just applying technology to a problem without thinking it through. One of my favorite examples of where AI can produce value is something that I worked on doing my PhD. So I'm actually quite happy to say I've built the world's most intelligent traffic controller, and it's all done in a very human-centric way.
Here is a simulation of traffic, applying traditional traffic management on the left and with the new method on the right. Notice how the queues with traditional management are much longer than with the new method. Follow the blue car with the red ring in both simulations and note how the car is coming much faster through the intersection with the new method. Looking at the difference throughout the morning rush hour, motorists save 53% in driving time compared to today's situation. Queues are 64% shorter and there are 21% less stops. Finally, 28% of the fuel is saved.
And all of these results are verified by the leading consultancy firm, COVI, by the way. So this is not something we just did in isolation. Everything was validated when we did this. So just a little bit about how we did it. So in quite many intersections now in Denmark, you have a new technology rolled out over the past 10 years, which is radars. And these radars are Doppler radars. That means they can see every incoming object in a pretty detailed manner, I would say. So here all of the dots represent individual cars seen by the radars. For all of these cars, you have a lot of interesting data, like where is the car in an XY coordinate, how fast is the car driving, which type of car is it based on how big it is, and so on. And what we then did was apply online reinforcement learning to this problem to optimize the flow of traffic. Again, pretty simple when you think about it, but the systems that are in place today are all rule-based systems where we sort of have this traditional paradigm of saying if there is a car 200 meters from the stop line, extend for X seconds. If there's one 100 meters, extend for a little bit longer, and just a system that's not really fit for the situation today. And while that's all good, one thing I really like with this case, especially in terms of how human-centric it is to use it, is how much easier it becomes for the road authorities to actually take back control of their existing systems. Because in the old way of doing it, if you wanted to change anything, you need to sort of tweak these parameters, the intergreen times, the minimum green times, and sort of just pray that this thing works out. Normally, if you want to do that, it would take up to half a year before you see any effect, because first you need an engineering company to go out and count cars and observe the intersection and sort of try to decide what to do. Then you need someone to actually program these new tweaks, and then you need to make sure that everything works. In general, this costs about 150,000 Danish crowns every time you want to do it. And the effect is no one really does it, so that's why traffic lights are working so horribly in, I would say, almost all of the world, because you don't really have these tweaks. But one of the cases we did was in Vejle, and something really interesting happened there. So what you see up here, I hope you can see my mouse. Yeah, exactly. You actually have a school, and in the morning rush hour, when parents were dropping off their kids at the school, the cars would stack up on the school ground instead of on the road, meaning it was impossible for the system to actually count these cars into the system. And not very long after the system was put in place, the principal of the school actually complained to the road authority that this new traffic light they got was really working badly, because at the moment it was, because we didn't account for the school when building the system. But then something really awesome happened. So a guy from the Danish Road Authority actually went into the intersection himself to look at the problem and see how the cars queued up around the school here. And then he just, because now we have a mathematical model of how to actually optimize the intersection, he was able to change the priorities. What you see here is that he actually decided that cars coming from the B direction, so this is the direction up here, should be prioritized as 2 cars instead of 1. Pretty simple, and the effect was seen immediately. With this now being a mathematical model, everything worked out nicely, and he could go home. All of it took him about an hour and a half. And the day after, he was actually able to send the principal of the school a diagram like this, where you can see that the priority is shifted, where now it takes a little bit longer for cars on the left turning lanes, so that would be here and here. And the new capacity is then given to the B turning lane, so that means our priority was given to the school instead of the left turning lanes on the main direction. So a little bit about human-centric AI and how I believe AI systems should be built when they are built for real-world applications and not just for academia and for publishing papers. The very place to start is with a problem. So it's really important to know what is the problem we're actually trying to solve here. And it sounds really simple when you say it, but I have seen a lot of people, especially in boardrooms and C-suites, going crazy about why don't we have AI, and none of them really have any AI problems. They just want to have AI because everyone else is doing AI, so we should be doing AI as well. Then you have the human part, I would say. When building AI systems, it is, in my point of view, really important to include both AI experts, that's someone like us, and domain experts. That's someone who really knows their domain. For instance, the traffic light system was built very closely with people from traffic engineering, so they could sort of say what are the pain points, what would be nice, what won't be nice, and what's actually legal to do. And then of course you need a way to get a lot of data, because without data you cannot really build any AI systems. Again, a little bit about how to actually work together. When you have a problem and a domain experts, that's usually where you have the business case. So of course it's also very important to think about what is the business case of what we're doing, what will the real impact be. One thing you also have from the domain experts will be the metadata. So it's really important to understand whatever data you're building your model on, how is it flowing, where are you getting the data from, and so on. And of course what we do as AI experts is to code stuff and try to optimize it as much as possible for the problem. And the last part I won't go too much into, but of course it's also very important to think about what are the functions you're building, what is the underlying architecture, so you know everything is fast enough. For instance, for the traffic light problem, we're building all of it so it can run on an edge system, because this is highly important for traffic lights. Interfaces are really important, because otherwise how do people use your system, how do they interact with it? And lastly, it is of course also very important to build good and robust models that fits into all of this. And when you have all of that, I would say you have achieved human-centric AI. And perhaps also just to focus a little bit about what happens if you don't focus on building human-centric AI. I'll not go too much into AI without purpose and purpose without AI. We see this a lot, but again, it doesn't matter so much. This is mainly a business thing, I would say. But when you then have the foundations for building AI, if you don't have the human part, so let's say, for instance, you're an AI expert and you decide to build a system without including domain experts, then you see a huge risk of bias in your model. For instance, what we just saw with the COVID-19 example, where you have sort of a data set and you believe as an AI expert, this is a golden standard. I can just do a 70-30 split and then everything will work as long as my model works, and then I can put it into production, and then the real world hits and you cannot do that. And MIT is really excellent at finding these cases, and they have published a wide number of articles about it. There are also a lot of where, for instance, you have a data science at a bank building a model on a data set that's only a subset of the real data set, and the bank loses a lot of money and so on. So really, I mean, always include domain experts, otherwise you're doing horrible stuff that doesn't make sense. And one thing we're also sadly seeing a little bit is domain experts who now, where AI algorithms are so available, so open source, are saying like, why do we even need these AI experts? I mean, I can easily just pull some code off GitHub, perhaps a model from Hugging Face, mix it all together, and then I have an AI system. I mean, why do we even need you guys? And we have seen this a lot, and what normally happens is that they build stuff that doesn't make sense. So they are either overfitting models and stuff like that. And yeah, it is really, really important to have both sides of the coin. And then a little bit about the process. Again, I will not go too much into details with this because I'm assuming all of you kind of know how to do it, but it is really important to focus on your input data, build your models, so this is your prediction, but also while doing this, thinking about what kind of actions can my model actually take. I mean, is this a recommendation system? Is this a fully autonomous system? What are we trying to do? And then, of course, it is also highly important to always measure the outcome of what you're doing, because otherwise you don't know really how to change your model, how to tweak things, and so on. And then you have, of course, the possibility to retrain stuff. But the most important thing I would say is the judgment part. Again, this is where people come in, where it's pretty easy to build these models and systems, but it's really hard to make sure you apply judgment to what you're actually doing and doing things that make sense. And lastly, I just want to finish off on a little bit of a commercial break. And I'm really glad to hear that Ben is actually in the audience, because the year before last year, he actually helped us with the Danish National Championship in AI, a competition I'm really, really proud to host in Ambolt. And we actually have a local presence here at DTU again this year. So what we're doing there is taking students through a number of use cases. This was from a 2021 competition. One of the cases was a computer vision case, was Waldo. One thing we also really like to do in this competition is ask the students to actually go out and gather data themselves and figure out how to solve this problem. So we'll tell you what the problem is, how we evaluate it, and then everything else is up to the students. Another one is a NLP case. Last year it was movie reviews. And a final one is a control case. And this is sort of the structure we go through every year. And here's one of the models working. And perhaps just to motivate DTU a little bit, in 2021, DTU was actually the winner of this competition. Then last year, it was Copenhagen University, and this year, you actually have the chance again. So I hope to see a lot of your students at this competition. And also a big shout out to all of the partners, AI Denmark, Direct, ATV, and Danish Data Science Academy. Thank you.
Thank you so much, Andreas. Let's see if there's some questions here.
Yes, I have a question from Ben, who acknowledged with a thumbs up when you mentioned him. Let's see. Can you explain where the main challenges are of deploying AI in the public space? Integrations, maintenance, etc. How do you work with often outdated infrastructure and lack of technical knowledge?
That's several questions, Ben. To be honest, one of the main questions that issues we saw when going into this was you sort of have monopolies in this space where everything needs to go through tenders, and it's a little bit hard for the municipalities to ask for something that is, I would say, special. And then you have all of these other more traditional companies trying to sort of maintain their monopoly. So that's perhaps a little bit more of a company-focusing thing, but one thing we learned in that case is you sort of need to really focus on the value chain and not just build AI on top of an existing value chain, but actually make the entire product. So you have something that is a full product that you can actually sell, where this AI part is just a component.
Thank you.
Excellent. Do we have other questions among the audience?
Yeah, I was thinking, isn't there also a risk of bias by including domain experts, where they might be thinking in conventional ways and not thinking outside of the box?
Very much so. One of my favorite projects was actually with the Danish military, where we met a lot of domain experts who were trying to sort of just encode their own knowledge into a rule-based system more than looking at what the data was saying. So we see that very much, where you sort of need to break down barriers a little bit, because you have domain experts who have been used to sort of like, these are the rules of the game, and if you don't code it this way, it's not going to work. So there is sort of an iterative process of sort of peeling off these layers and sort of showing them, let's have a little bit of a look at what the data is saying, and then circle back to how we perhaps remove some of the things that are wrong in the data, if there are things that are wrong in the data. So definitely it is important to work together with the domain experts and not just work from whatever you get from them.
Thank you. Any more questions from in here? We got one over here.
Thank you. Very nice talk. What do you think about ChatGPT, where the expert can ask question, describe his data set, and get the code ready to run?
Perhaps instead of drilling down on just one of the large language models, I would perhaps more like to say what I think about them in general. And I think it's a wonderful technology. The way I kind of see it is as the new operating systems. So this will be something that is so essential to use in order to be productive, that everyone will need to sort of learn how do we work with these systems instead of working against them. So my way of viewing these systems are sort of like the new operating systems, where you will see a few big monopolies in this space, and people will learn how to use them in order to be effective. And if you don't, I think you will be left a little bit behind.
Any more questions? If not, I have one that I'm curious about. You mentioned that when you had the Venn diagram, that some cases are good for AI and some cases using AI is purposeless. Can you reiterate a little bit about, or maybe elaborate on, when should companies use AI and when is it just more rule-based?
Absolutely. I would actually argue it's already in the model. So when you have a problem that is well defined and measurable, and you have your domain experts signing off that you have a good business case on having this problem solved, and you have data supporting a solution for that problem, then AI is perhaps a really good solution for it. Perhaps also you can do it in a rule-based way if it's a simple problem. So I would say the tiers of problems that you can automate or solve with AI is much more rich than what you can with rule-based systems. So for instance, if you have data that is text, images, audio and so on, then it all falls into the domain of AI. If you have something that is perhaps looking at a couple of values and making decisions from that, don't automate it. And also if you have something that contains a lot of judgment. Another case I also normally use when I talk about this for a negative case was the company Zillow. I don't know if you know Zillow. It's an American company, sort of like the Danish Boligsiden, where you can list real estate and then people can go and look at that real estate. Zillow then got the idea to use AI, a very classical use case for AI, house price prediction, to build what they call a Zillow estimate. And that was, from a marketing point of view, a brilliant idea, because then you could upload pictures of your home, a description of your home, and so on, and then you could get a Zillow estimate, and then you could decide, oh, perhaps it's time to list my house on Zillow, because wow, this is a lot of money I've gained from just living here. A little bit further down the road, Zillow then decided to start buying some of these houses. So if you're listing a house on Zillow, the Zillow estimate says, oh, you're off by a couple of $100,000. Here's a Zillow offer instead. Let us buy the house. And they end up buying more than 25,000 American homes this way. And I would argue that buying a house is very much a judgment decision. It's something that's hard to build into these AI models. So of course you can make models that sort of can predict a house price. But again, there is a lot of judgment involved with what is this neighborhood like, a lot of touchy-feely stuff about buying a house that you cannot really automate. But Zillow tried to do it anyways. Then in the third quarter last year, because of some of the macroeconomics changing a little bit, they had to write off, I think it was about $300 million in property value on the houses they brought. They discontinued the program and the stock price fell more than 22% in one day. Perhaps the biggest AI fuck-up of all time, if you look at it in economical terms. They lost billions of dollars of that from their market cap and had to lay off, I think it was 3,000 employees. So if you have something that involves judgment, don't automate it.
I think those are wise words to end on today. Thank you so much, Andreas.
Thank you.
So that was the last speaker for the day. Thank you so much for joining. You have the opportunity again on March 16th, where we have Sheeta AI and Diverse coming to speak to us about AI. Have a great day.